Hello, can you hear me? I can hear me. I'll assume that you can too. How's everyone doing? I appreciate you coming out, considering that there is multiple happy hours happening right now. If you didn't know that, I'll forgive you if you leave. That's okay. I'd like to welcome you to ARC338. This is how Goldman Sachs minimizes the impact of managing events. I'm actually Brian Carlson. I'm the Operational Excellence Lead for the Well-Architected program. So who's familiar with Well-Architected? That is wonderful. That's the largest number of hands I've seen so far this week. So the Well-Architected program is a set of best practices. It's a framework that you can adopt to help you produce effective cloud-native architectures. It's all about minimizing risk, things like that. I have jumped ahead a slide. I apologize for that. Today, I'll be welcoming Elaine Hardwick and Sujoy Saha from Goldman Sachs. We're going to talk about the ways in which they've minimized the impacts of events, specifically using services such as EventBridge and OpsCenter. Well, let's just dive in. So a little roadmap of where we're going today. Obviously, I'm giving you a little bit of an introduction. Then Elaine's going to talk about the operational challenges that Goldman Sachs faces, some of them unique to the space in which they operate. They're going to talk about automating operational excellence and the ways in which they reduce their toil and their burden for their operations staff. I'm going to follow that up with some really interesting case studies that illustrate ways in which they have optimized responses. They're good examples. And then finally, we're going to have some conclusions about the ways in which they adopted and the things they want to do next. All right, so Well-Architected, as I said, is a set of best practices. It's a response to challenges that we see our customers have. It's actually full of all kinds of things. Now, this slide's a little overwhelming, and I'm not really intending for you to read it, so much as I want to show you the things that are present. First, we have content, and within that, we have 5 pillars. Let's see here, operational excellence, security, reliability, performance, and cost optimization. And within each of those, we have design principles, which are things we want you to focus on. We also have best practices that are answers to questions that we ask. There's white papers if you like reading white papers, but the easiest way to get to it is to actually use the tool. And within the tool, all of our content is there as well, in context. Free to use, all this content is free. All this content is agnostic. To actually get to a reference to an AWS service, you have to go 2 layers deep. It should apply to your on-prem, your cloud. It should apply everywhere. And then finally, you get data out of this. Within the tool, you can store reviews of your systems, establish milestones to track changes over time. So you can use it as a tool to help you to review where you're at, what your risks are, and understand them more effectively. All right, so let's step ahead a little bit. The pillars of Well-Architected. Operational excellence is the first pillar. It is not the most important pillar. Now, usually I let reliability and security fight it out there. Because if you don't have security, then you can't establish trust. If you don't have reliability, you can't actually perform for your customer. So I think those two are probably the peaks. But operational excellence has the most important question in all of Well-Architected. Ops 1 asks, how do you establish your priorities? It's a focus on your customers, your compliance requirements, the way you manage risk. And if you can answer that, and everyone in the organization understands their part in achieving business outcomes, you're grounded to be successful. Next up, security, then reliability, then performance efficiency, and cost optimization. All right, so stepping ahead into OE, I like to view every organization as a 3-legged stool, and you're trying to elevate your organization, step up to that next level. There's 3 legs on that stool. There's the business. Operations and development exist to support the business. Then there's development. Developers own the future, right? Because they're the ones who are creating the innovation that is propelling the business forward. The business is asking, the developers respond. And operations are the people who make sure that we can deliver on that. Operations can compensate for weaknesses in developed products, but they also can make sure that those are resilient to things going on in your environment. So ultimately, there's 2 major points here. We're trying to deliver business value, and we're trying to ensure we continuously improve. All right, so today we're going to focus on 4 design principles, specifically perform operations as code. When we do this, we limit the introduction of errors from manual activities. If we script it, it's going to be executed consistently, so we ensure that consistency. We're also going to talk about refining operations procedures frequently. If you can make an improvement and you have the time to do so, do so. So going back to that operations as code, you can treat it with the same engineering discipline as code, right? You can have versions of your runbooks. Everything starts with a manual process Then you codify it, then you identify an event that can be used to trigger that response, and you eliminate toil. When you refine your operations procedures frequently, what you get out of that is this iterative improvement cycle where you can reduce toil in your environment. And then we talk about anticipating failure. Werner Vogel says everything breaks always. It's true. But through operational excellence, if you can anticipate failure, ideally you remove sources of failure. The only way to get to 5 nines of reliability, the last 2 nines come from operational excellence, as your operations teams work with the development teams to remove sources of failure and increase the probability of having that successful outcome. Beyond that, where we can't compensate for risk or things that can happen in the environment, we can plan to respond appropriately. And in that way, we can ensure that we have an effective response. And then finally, let's learn from all operational failures, which is very much like refine operations procedures frequently. If things break, let's prevent the recurrence if we can. Sometimes people talk about blame-free postmortems, reviewing after the fact without blame. And you know what? I think it's reasonable to have that as an aspiration. It is more likely that we have to have a conversation where we understand that things go wrong. However, if the same thing goes wrong for you 3 times, we're going to ask some questions. So it's a consideration to have there. All right, so what we're really asking you to do is design with ops in mind. When you think about it, your workload, hopefully, the majority of its lifetime is spent in operations. So if you're investing time in development, ideally that's small compared to the long tail. So the investments you make in effective operations pay off in the efficiencies over time far greater. So let's design with ops in mind. All right, so today we're going to be talking about OpsCenter, and we're going to be talking about aggregating operational issues into one place, a centralized console, a place where you can view all this information, where you can actually augment that information, assisting in diagnosing and remediating those events. So it's like your dashboard or your cockpit for responding to events. All right, now, as you can see, there's a whole lot of best practices from OE and some design principles all over that can be seen inside of OpsCenter. And in fact, it's literally covered with them. Terrible joke, I apologize. All right, so between AWS Systems Manager and OpsCenter, which is a component of it, you can drive through to operational excellence. And with that, I would like to welcome Elaine to the stage to talk to you about Goldman Sachs.
Thank you, Brian. So just to give you a quick start, Sujoy and I are both from Goldman Sachs, as Brian mentioned. We're part of the core engineering team, so specifically we're both on our public cloud team, which focuses on design best practices, patterns, and architecture within the public cloud space. Goldman Sachs is actually celebrating its 150th birthday this year, so we're really excited about that. But when you think of a company that is 150 years old, you may not associate it quite with the term innovation, right? You think of something old and stale and stagnant. I want to tell you that that's not the way Goldman Sachs really is. It truly embodies innovation and drives us as employees to continue to design new and innovative things. So with that, we have over 33,000 employees at Goldman, and somewhere between a third and a quarter of those are actually engineers. So we are really focused on innovation, and we are really focusing on our clients. So with technology driving a really big presence in the financial services industry, we're always focusing on new opportunities, and we're trying to seize those and really impress that upon our clients. And then we are also trying to make sure that we're establishing best patterns and procedures while we're doing these innovative solutions, because if we don't do that, then we're not going to be successful. So let's talk about a couple of our use cases. We first started off with our compute engine, moving that into our compute extension. We had a private compute farm, and we started taking that into the public cloud. We wanted to do that for liquidity and capacity, and we were able to shut down several of our colos and move a significant workload into the public cloud because of that. We then looked at our lift and shift, so certain applications that needed to be closer to data centers for their clients' needs or that had a lack of dependencies. We focused on moving a few of those products. And then we've focused a lot on our innovation. So like I said, we have a bunch of engineers. We wanted to provide them sandboxing capabilities. So we actually have a separate organization that we've set up so that all of our developers can have a playground to learn and innovate. And then if they can provide something that's helpful to our clients or to our firm, we bring that into our other organizations in-house. We also, from innovation, you may have heard on the keynote, we do a lot of new exciting business opportunities. So any of those, we're definitely looking to leverage the public cloud as well. And so that's another area where we're really focused on innovation in the public cloud space. And then lastly, we have our business continuity and resiliency. And if you went to another one of our talks was on the Tale of Two Cities, and that one was talking about our investment research portal and how we were able to take something on-premise that needed to have a disaster recovery initiative and pull another area into the public cloud space. So the other thing to note about Goldman Sachs is we have 14 business principles that we really, truly feel like define us as an organization. And one of those is our business principle 11, which we thought really kind of associated with this talk that we're giving today. So we constantly strive to anticipate the rapidly changing needs of our clients and to develop new services to meet those needs. We know that the world of finance will not stand still, and that complacency can only lead to extinction. So as we're moving more and more of our workload into the public cloud space, which is an ever-changing environment, the need for our standardized processes and procedures is really paramount to our success. We cannot focus on our clients' rapidly changing needs unless we can establish that strong operational excellence. So that's why we focused on that today. So before we can achieve operational excellence, we really have to think through the operational challenges that we're facing. And if any of y'all have seen this email from AWS before, this is an email that will tell you that your degraded hardware is occurring on your EC2 instance. I'm sure several of y'all are familiar with this. As a level 1 support person, you may not know exactly what to do, right? You might not understand who owns these resources, what actions need to be taken, what needs to be tracked, how to escalate if you can't solve for this. So it can get really confusing over time. Like I mentioned, events occur a lot. You might have an email or a CloudWatch event that's triggered. There can be several different ways of getting that. Then someone may call you and say, hey, my system's down, go fix it, right? If you do, then you're gonna have to manually track that event, right? Upload that into some kind of system. We currently use Jira. That change might be approved. You would have your developer either execute some script, log into the console possibly, execute something, and then hopefully it's resolved. You may or may not have that postmortem, right? That discussion of what you've learned from the event, how to approach that and resolve for that. So this is something that definitely needs to be addressed if you're going to be doing this at a large scale. So Goldman Sachs has thousands of accounts, right? We have 2 different organizations and a lot of things to manage. We're also across multiple regions. So when you're looking at these emails that are popping up for that volume of accounts, that can get a little daunting, right? You don't want to have to go into each and every account to see all of these issues that are popping up. And as a level 1 support person, you're going to be severely overwhelmed. Manual intervention can be extremely overwhelming, right? You don't want to have to log into each of these, figure out what to do, and have someone manually spend their time doing each and every one of these tasks. Your escalation points might not be clearly defined. If you don't know who actually created that Lambda or what that Lambda is supposed to be doing, you may not know how to resolve for what's going on there. Resolution operations may not be codified, right? So like I talked about, if you're going into the console and executing some command, you're not going to be following the same SDLC patterns or best principles. You're not going to be able to vet what's going on. There's going to be a lot of issues that you're going to face. So in an operational excellence micro account model, we would really strive for aggregating all of our operational items centrally, right? We want to take everything and pull it all into one centralized space for any of our operations to be able to mine that data and do support on it. We want to define automated workflows. So once you've got this centralized repository, right, you can do trends on it. You can analyze what's going on, what's happening more frequently, and then you can determine which tasks need to be automated. If you can't automate these tasks, or if they're deemed not critical, then you need to define some way of escalating these incidents, right? You need to kind of walk through and make sure that you know how to step it through in that manual regard and what steps that person needs to take so they don't have to spend the time figuring it out. And GS has a certain additional set of requirements. So as a financial services industry, we are severely regulated and very much audited. And so we really have to focus on that end-to-end root cause, actions taken, walking through that entire process and being able to pull that back to all of our auditors throughout the entire process, right? So if an incident happens, we need to show that entire life cycle of that incident and what we're doing to improve that process so that we're not having to go through that same cycle every time. So now that I've explained to you all of the problems, I'm going to have Sujoy talk to you about how to implement the solutions.
Thank you, Elaine. Let's see. So in order to start achieving operational excellence, we took all our different compliance and audit requirements and folded that into our operations like workflow and how we respond to those. So So there are, if you look at our existing operation event management system, we would see that there are primarily three major pain points. The first one is data collection. For a new team starting out and like starting to onboard to the cloud, you have to have like some like existing way of capturing information regarding your account. This would be in terms of different cloud native services and different event sources that would capture logs and other operational events that are happening in your account. And then you would need to be able to process that and like store that somewhere. Right now it's a manual process. However, like as we go through the slides, we'll see how that becomes more automatic. The next bit of like challenge that you will have to face is that you'll have to be able to capture enough information as possible to deal with an event when it happens, and then appropriately curate that information in such a way such that like downstream systems that do respond to these events are able to make the correct remediation possible, as well as make sure that whatever actions are being taken are appropriately logged and associated with that specific event. And finally, if you're using like specific scripts to like remediate these events, there needs to be some place in which you are keeping track of this information. Oftentimes we'll see that whenever like a certain incident has happened, for example, the EC2 degradation event, right? Like we will open a Jira ticket which will say, okay, this instance is down, and then it's assigned to this user to go and fix. They won't really mention that, okay, this user did like this specific task and executed this specific script to restore that instance. It'll just say that, okay, this after a certain point of time, that person has taken care of it. So we want to make sure that we capture that information as part of our event tracking system, like entire end-to-end life cycle of that event as well in that process. And finally, like this will actually help us achieve the appropriate like post-mortem alerting and incident recording, as mentioned by Elaine earlier. Like this will make sure that if we have all the details that we need for our event in a central location, we'll be able to like look back at it and take remediation steps later on, and like take appropriate steps to change our workflow or change our processes that deploy those resources so that they're more resilient in the future. So with that, let's look at the way we solved the first challenge, which was central event aggregation and making that system available for our client teams. So right now we look at like different Amazon like cloud native services that already have like a huge treasure trove of information. One of them is AWS CloudTrail. So CloudTrail allows us to capture every single event and every single API that was invoked by either some user or some role that's in the account. This can be like, these roles can be assumed by entities inside the account as well as outside of the account. And then for us, we can actually look for specific events that like we are interested in. One such event is when we do an upload of a Lambda function. In that case, like the CloudTrail event that we capture is that the Lambda function is updated, and then we can run appropriate tests on that to see, okay, once this function is updated, does that break any production environment? Does that have any impact on any other resource that's in the account? Another example of a cloud native resource that we take is AWS X-Ray. X-ray is very useful for application type of resources. This can be in terms of like jar files or binaries that are running on EC2 instances that have taken on the X-ray dependency and are able to like capture traces as well as like different API calls that are being made by that service as it's running. In addition to that, like we can also capture like information about the latest trace IDs and other specific like inspection details that we can use to like do an investigative analysis of that. And using that and parsing that information, we can actually come up with interesting remediation strategies based on the type of error. If, for example, your application is running into like a access denied error, that would result from potentially like the service not having the appropriate permissions. And then we can have some appropriate remediation tasks that can go in and add those permissions if needed. Another service that we found was really useful was that of CloudWatch. Already, this is one of the primarily most used service for in terms of like alerting and monitoring. One of the most used resources that we see in our production environments is that of CloudWatch alarms. Alarms help us identify what are the different resources that are impacted by any service outage, or if, for example, a specific resource is undergoing maintenance, we can always see that there. In addition to that, we can always configure like custom event or time-based rules that we can take advantage of, and then we can always capture events coming from that and have appropriate automations run off of that whenever we capture those. Now, you might be wondering, we've got 3 different sources of information. How do we like collate all of them together and make it available in a format that we can process in an event-driven manner? For that, we use a new service, which is the AWS Event Bridge, which basically allows us to capture like events from all different cloud-native sources, including third-party providers, and downstream that and make that available as an event on a specific event bus. While these events are not in any like specific order, we can always capture these events and make it available for other downstream services to react to, and as well as make it available for like either like like a Lambda function that reads these events and take action on that, or we can have like other services that can like inspect those specific events and then take action on that. We can have, and we do this specific thing through what is known as event bridge rules. So we can configure custom rules to capture these specific events, either in CloudTrail, X-Ray, or CloudWatch. So now, once we have all these events available in EventBridge, what we want to do is we want to take appropriate tasks for these events. We want to be able to respond to each specific event with an appropriate task. And for that, we use what is known as a Taskmaster Lambda. We wrote this as a event target for our EventBridge bus. And what this does is this basically parses the event. It gathers as much information as it can about a specific event. Once it has all the information that it needs, it'll do some additional like analysis to identify what is the root cause. As I mentioned earlier, for example, if your application runs into an access denied error, so from that what we can glean is that the service does not have particular IAM permissions. So we'll capture that information. Next, what we will do is we will, once we have all this information, we'll create what is known as a ops item. As Brian mentioned earlier, we are going to use OpsCenter to track all our events, right? So we'll take the event, we will gather as much information as we can, and we'll put it inside OpsCenter with the relevant contextual information and data that's necessary to take appropriate remediations. Now, we do this for all the events that we receive from either CloudTrail or like other CloudWatch alarms and other resources. Using this approach, for every single operation event that happens in our account, we create a unique item to track that with all the relevant information that we need to do any further processing. Now, in addition to the information from the account itself, we will also take the ops item for that event, and we will also capture the relevant escalation information. When I mean escalation information, this is about, for example, if an event is related to a resource, that resource is usually owned by like certain business units or certain teams. In cases like that, we will have like the appropriate information of contacting those businesses as well as like the people responsible for maintenance of that resource. That way, we will encode the tracking information as well as the contact information of the person who's responsible for that resource inside the event, inside the ops item directly. The next bit is very important, and this is where our whole workflow comes into play. We take all the events that we get, and using our Lambda function, we basically identify what kind of remediation workflow that we can run for those specific events. And we tag that information into our ops item. And one thing I should mention before I proceed, already in EventBridge, you have a capability of creating a rule that automatically creates an ops item for a given action. For example, if you have something in CloudTrail that resembles like some service outage, you can directly create an ops item from that. However, we've seen that the directly creating ops items often does not have the enough information from the parent source. In this case, CloudTrail will just have, okay, this resource has this issue, but it won't capture additional tag information. So you'll always have to make additional API calls to get that. So using our Lambda function, we are able to do those appropriate, we can capture those information with additional API calls. Now, let's look at what this ops item will look like for a given event. We primarily capture three sources of, I would say, or three components. The first one that we will capture is the root source of that. So we will check. We'll try to identify what service is associated with that given event. For now, we are just looking at compute databases as well as backup and storage. And in either of these cases, what we'll capture is basically the identifying information of that resource, as well as the account number, as well as the region where the resource is located and is affected. The next piece that is very important for us is that of the operational data, like the day-to-day runtime activities, as well as what are the different components or dependencies of that resource. The four primary things that we found were very useful for us was that of the IAM role that is assumed by the resource to perform any action, the X-ray or traces or logs, like log streams in CloudWatch, that kind of thing. Once we have that information, we can attach that to ops item, and that will ensure that we are capturing, when we are creating a ops item for a given event, we have the latest, we have the link to the latest logs for that resource. In addition to that, for different services which have some kind of backup capability, we will definitely try to capture the snapshot IDs of the resource. For example, EBS volumes, where is the last backup of that taken, we'll try to find that, and we'll source and we'll place that into our ops item. In addition to that, and this one we found was really useful, was that of artifact sources. Now, earlier in our session, we talked about applications that are running as Lambda function or as EC2 instance, or in EC2 instances. In either of those cases, you would have uploaded the binaries or the executables through S3. Or if we make a broad generalization, most times we've seen that people store their artifacts on S3 and then they downstream that and use that to actually invoke their Lambda function, their functions. In either of those cases, we'll capture that, so that if for any reason we can restore and rerun our application, we can do so. Finally, we'll also capture all the different tags that are available for that resource. This will include team and business unit identifiers, the alert, whether it's a production or non-production resource, we'll capture that, as well as the relevant escalation information. So let's take a look at a quick example for this. For the earlier hardware issue that we experienced, and we got an email from Amazon saying, okay, your hardware has undergone degradation. In that case, we'll capture, for the root source, we'll capture the instance ID of that resource, as well as account and region. We'll capture the instance profile in the operation data. We'll get the latest EBS volume snapshot IDs, and then we'll get the appropriate tags that are there on that resource. Now, once this ops item is created, we want to have the capability of instantly responding to that ops item with an appropriate action. So we have what is known as an ops monitor Lambda that looks around for basically whenever a new ops item is created, it is invoked and it executes a appropriate remediation. The remediation that we run is in form of a SSM document that is uploaded by the business unit or team that manages that resource. In this case, SSM document is nothing but a Systems Manager document, which is basically a script that executes certain actions against a given invocation. Once you pass certain parameters to it, it'll take action on that. Now, and a good advantage of SSM documents is that you can actually configure and pass on different rate controls to that, so that you can execute either a few of them in parallel, or you can either, for example, you can also have something that uses branching workflows. In this case, if you run into if you can configure something like an error threshold, such that whenever your automation document runs into some problem while executing on you against a specific event, it can actually send out specific alerts if it goes into any error. So in this case, we ran our automation document and it succeeded without any problem. In that case, yes, we'll close down the ops item. We'll say that okay, the event has been remediated, and we can now go on to the next remediation stage. However, if it ran into a problem, we'll send out a failure notification, and this will be passed on to the business unit using the identifying tagging as well as escalation information that was available, which we captured in our ops item in a prior task. Now, in terms of alerting, what will happen when the automation fails? In cases like this, we will basically categorize the kind of failure that our automation ran into. We'll classify something as a critical failure when, for whatever reason, for a given event, our tagged automation wasn't able to execute, or it ran into some failure and it didn't work at all for any given time. Whenever we have that error threshold achieving almost 100%, that's when we'll say, okay, we need to send out an alert. This needs manual intervention ASAP. So we'll send alerts to as many notification platforms that are available to us, and this is something we can gain from our ops item tags. In addition to that, we'll notify different levels of support so that they can intervene, and while we expect DevOps people to basically write the remediation scripts, we'll also notify different levels of support so that they're aware of it, and that they know that okay, DevOps people are working on a script, and they're going to release that to fix that. In addition to us tracking that. Now, if you look at some of the other alert categories, these are basically taking advantage of the error threshold, rate control that I mentioned earlier for SSM documents. We will, if for example, we have failures that are occurring above a given threshold, we'll send out high-level alerts. We'll inform support that, hey, we are seeing increased error rate for your specific resource. We would like you to investigate that. For the lower categories like medium and low, in both of these cases, we expect that support team should be notified to some extent. For medium cases, it happens when we observe failures, but they don't go beyond that given threshold. So in those cases, we'll contact the team. We'll tell them that, hey, something's going wrong. You have to take some action at some point. For cases where there are transient errors, and this happens whenever there are issues with AWS services, in those cases, we'll just make it available on SNS topic so that they can keep track of, if someone requires it, they can keep track of it. And however, we won't be responsible for looking at those. Now, in the case of the critical alert, where DevOps had to intervene and write a new script to remediate that action, we define a SDLC workflow for that. What we expect them to do is they will commit a specific SSM document with the necessary remediation steps. And once that is gone through code review and code scanning and all the different things that we have in our firm SDLC, once it's been peer reviewed, it'll actually get pushed and applied into the Amazon environment that has all their resources. Once it's available there, they will use either the DevOps console, and this is something that we give we make available for different business units who have production and non-production accounts. They'll be able to execute these automations via script, or in some cases, we also allow them to execute these manually. In either of these cases, if they're able to successfully execute that automation document, and it has appropriately remediated that specific resources, like event that has occurred, they can successfully say that, yes, our remediation script is ready and it can be used for production. In that case, what they'll have to do is that they just have to tag that automation for use. And what this means is that at the next, whenever this incident happens again, that caused the original outage and we were not able to respond to, whenever that happens, this newly tagged automation will be picked up by Ops Monitor. And after that, it'll be able to execute that automation. And going forward, whenever an event of a similar nature happens, it will be able to run that and successfully associate that with that specific event. So now we have a workflow where we had, initially we had to do some manual intervention. Yes, it took some time for us to write a document necessary to respond to that event and take action on it. But from now on, we don't have to do any more manual interventions. In case there are more failures, we can again go back to this SDLC process, make changes to the automation document where necessary, so that it can be rerun in more cases. And if you do run into errors again, you can go through the process again, and once you have a very robust set of documents, you will now have far lesser use of manual intervention, over a longer period of time. Earlier in the day, we had a presentation about, from our GIR team, about the zero packed usage, the zero production access usage, and this actually feeds in very well with that, because what this means is that for teams that are newly starting to adopt the cloud, they can start using this approach to deal with events that are unexpected, and they can start taking action on that, and that will actually reduce the time taken for them to get into a good and optimal state of production quality. Now, let's take a recap of the system that I just described. So we will capture events from different sources in EventBridge. This will be from from all different cloud-native services, including third-party vendors. Once these events are there, for each individual event, our Taskmaster Lambda function will create new ops items. Each ops item, of course, will have the relevant information and details necessary to take action on those, for those events. Once the ops item is created, the Ops Monitor Lambda function will run the appropriate SSM document for those events and will basically associate that to the ops item. And if the automation has been successful, we will just close down the ops item to indicate that the event has been remediated, and we can close down the task. If operation has failed, however, as I explained, we will send out alerts with different levels of criticality to appropriate business units based on the tags that we got earlier, and so that they can take manual intervention through the specific SDLC process that we showcased. Now let's take a quick look at some unique case studies where we've taken this approach and applied that for our team's products. In the first case is with Lambda deployments. Now, to give you some background, in the past, whenever our team or any team in general used to test out or write a new Lambda function, it was always very difficult to run that initial test and see if it's working against a given environment or a given set of resources. In those cases, what we would have to do is we would either have to configure different CloudWatch dashboards or have SNS topics, or look at X-ray to actually see if whether or not the Lambda executed properly, where all the API calls made properly, where the logs looking all right. We have to do all of that steps, and it is quite a tedious manual process. However, with this approach I just described, what we do is we monitor CloudTrail for a very specific event. It's called Update Function Code 2015 March 31st, version 2, uniquely named. But yeah, we basically look for that specific event in CloudTrail, and what that means is whenever the Lambda function was updated, right? we will capture that specific event and then create a specific ops item for that, which basically tracks the fact that this is a new Lambda deployment that just occurred, or Lambda deployment has been updated with a new source code. Once that is there, we will execute the appropriate post-deployment document. This would be basically what this document would do. It would invoke the function with the appropriate parameters, or it would set up resources in advance so that it could the Lambda function could be run on them, and then it would basically perform checkouts to see if the whole process worked without any human intervention. This specific way of doing things allowed us to save a ton of cycles of developers' times. They wouldn't have to spend time now to look at CloudWatch, look at logs, look at X-ray to see, okay, is our Lambda function running properly, or once we updated it. In addition to that, this basically is an automated test, so it really works well for us. The next bit is with the error controls and, the rate controls that I mentioned earlier in the presentation, you can actually have different settings such as concurrency, which as I mentioned, was how many parallel instances or concurrent instances you can have of that Lambda function. So you can test it against various canary resources of different settings or different parameters, and you can do a large number of tests from that. In addition to that, you can have different error thresholds, and using these error thresholds, you can determine whether or not your Lambda function is ready for deployment. If your Lambda function has while running these automated tests, goes into you find out that it crosses a specific error threshold, we can basically send out alerts that, hey, the deployment failed. And we can, and using different, the information in the ops item, this would be the source of the Lambda function. As I mentioned earlier, we capture the source ID, right, or the artifact source. We will be able to find out, okay, this Lambda is located in this S3 bucket, and then we can re-upload the previous version of the object that basically is the Lambda function zip archive. Using that, we can ensure that at any given stage, if our Lambda function deployment does not satisfy our automated tests, we can perform an immediate rollback, and that service itself would not be available for any other downstream services to interact with. That way, we can ensure that our applications have a high level of quality, and we can perform automatic rollbacks whenever they are not. And that actually increases a lot more confidence from our clients who consume these services. And as I mentioned earlier, for the other side, path, if the Lambda function was successful and all tests were satisfactory, we'll keep executing the Lambda. We'll keep promoting it to higher environments until it's available in production. For the next case study, we'll take a look at EBS backups. For the one that I just described with Lambda functions, it's non-standard use case. It's something that's more specific to us. However, as I explained, using this specific approach, we can automate a lot of different tasks. One of them is EBS backups, and my colleague Elaine will explain that.
Okay. Hello. Okay, great. I'm going to hold it. So as Sujoy mentioned, with this pattern and this procedure, you can apply it to multiple things, right? So it's not just a one-time done thing. This pattern can be applied and reused and revetted. So with the case of EBS backups, the first thing I wanted to talk about was just kind of giving an overview of AWS Backup. Has anyone used this service before? It's relatively new. It came out in early this year, but it's something that we use heavily at Goldman. And the reason why we're using it is we have several distributed teams, as we've talked about. So those distributed teams would have to understand all of our compliance patterns, understand how long to maintain all of these backups, right? They're also going to have to make sure that they understand the cost associated with all of these backups. So there's a lot of steps that everyone has to go through, and we really wanted to make sure that there was a holistic and simplified way for our teams to make sure that they're following those standardized compliance patterns and procedures. AWS Backup will create a centralized vault per account per region, and it will allow for multiple backups of multiple different resource types. So I think it's EFS, EBS, RDS, and storage gateway right now. And all of those can go into the same centralized vault. So again, it allows for that holistic viewpoint, but it's going to help all of our developers not have to think through all of the complicated requirements around the legal and the auditing side. So in order for those developers to get their stuff into AWS Backup, we created an EBS backup module that we've deployed to each of our accounts. The great thing about this is the developer, all they have to do is tag the resource with the correct backup module tag, and they will get this awesome thing applied to all of their resources, which will, one, put it into that centralized backup vault, two, apply the lifecycle policies around it, so it won't retain these backups for too long. It won't cost the firm extra money, all of the great stuff that's associated with that. And three, it's going to put recovery point tags on it, so it's easier for us to recover and won't continue backing up the backup, which is really important as well. So the next step of this is to leverage the same pattern and principles that we've talked about throughout this entire process to do the EBS Backup Restore. Before I get into this, though, let me just walk you through what an EBS Backup Restore would look like if you didn't do this process. First thing that you would have to do is identify that that resource is down, right? So you'd get that email or that CloudWatch alarm, and you'd have to go in and figure out which instance it was, which account it was in, which region it was in. Then your developer is going to have to identify which volumes has the issue, right? Which volume's corrupted. Next, they're going to have to stop that instance, detach that volume, find a backup of that volume, right? Reattach that to that instance, respin back up that instance, and assume that everything's going great. That can take a lot of time. That's a lot of, discovery. It's a lot of work for your developer, and this pattern will help eliminate some of that. So you get your alert in your CloudWatch alarm, goes to your event bridge or your event bus. The Taskmaster Lambda is taking care of enriching that item, adding that volume that's associated to it, making sure that the owner that's responsible for this instance is included into that information, so into that tagging. Your Ops Monitor Lambda is kicking off your SSM document that's walking through all of those manual steps that we talked about previously, so your developer, again, doesn't have to do any work here. Going into that backup vault, restoring it from a centralized place, and if everything goes great, your instance is back up and running, and you don't have to worry about it. If something fails, as we talked about, your developer has a way of getting notified that this is the issue with their resource that hasn't been backed up successfully, and they can go into it and take action upon it. The other thing to note is if this happens multiple times across multiple resources, it's the same pattern, it's the same principle, it's the same procedure. So it's really nice to keep implementing that. Okay, so I know you've seen this slide before. You're probably wondering why you're seeing it again. But now it's really pretty because we've actually solved this problem, right? We can monitor across all of our accounts. We can monitor across all of our regions. We understand the issues that are associated with the different standards and principles across all of these, and we can check this box off. We also have talked a lot through our resolution operations and how they're codified now, right? We can go through that same SDLC pattern that we're dealing with our software development cycle, but we're applying this to our infrastructure as code. So we're got another checkbox. We've automated several of these tasks now. So Sujoy and I gave a couple of examples, but again, you can keep using this same pattern to apply throughout several use cases. And with all of our tags and our enrichment of our ops items, we've now got that escalation path really clearly defined. Any kind of support analyst can go through and know who to contact if there's an issue. And we've simplified that human intervention. Hopefully we've reduced the number of alerts that they're having to deal with manually, and hopefully given a clear path on how to resolve those incidents. So with that, I'm going to let Sujoy talk about our challenges and future work.
we got out of this. One of the challenges that we faced a lot of challenges as well. One of this was the fact that at the time when we started looking into the OpsCenter product, it was still recently launched. The service was launched, I believe, in May of this year. So we started looking at SSM documents as a process by which we could start remediating events and start using that specifically, as Elaine mentioned, right, as operations as code. Basically, it will allow us to codify our responses and then have that go through peer review and our firm SDLC. However, there was a challenge, and that was that you would now have to learn how an SSM document worked, and you would have to deal with the specific issues with its YAML structure. It was a new language with its own DSL. So once again, you would have on top of onboarding to the cloud and learning all the different Amazon services that keep coming out, you'll also have to look at this new platform, and you'll have the added challenge of adopting it. The other bit was that in the very beginning, there was some issues with passing parameters to the different automation documents. You could only pass strings, and there were other parsing challenges inherent to that. However, I'm happy to report that as of last month, with a new feature in OpsCenter, we were able to start using standard Python and Node.js scripts to basically remediate against against events. Basically what it would look like is you would have the specific SSM document executing different scripts, and you can have different steps in that, such that you can pass parameters to each one of them, so that it really flows well in terms of a multi-stage remediation workflow. In addition to that, the other challenge was with defining new automations for new events. This is for cases where you would not have seen a specific event before and you wanted to take action against it. So for that, there was always a challenge that, now that we are asking people to start looking at writing automations to deal with unexpected events, it would take time for them to go through our SDLC process, right? That would actually add in some lag and delay to your response. However, we are still trying to manage that and understand the trade-offs between that, and we'll make more progress as time goes on. In addition to that, there's always the standard OpsCenter limits. Right now, you can only have a certain number of ops items available in the account for a given period of time. I believe the limit is 500,000. It may sound like a lot for a given account. However, for very large deployments that are located in a single account, the fact that we are tracking each error or operational event as its own ops item, it does get challenging to scale it. So we do hope that OpsCenter over time will improve with the service limits, and it'll be more easier for us to work with. Finally, we still don't have much of an integration with GS incident management systems and trackers that are running on-prem. So we want to do that at a later stage. For alerting, we want to use our internal communication channels, and also have some integration with our Jira board for tracking. However, despite these challenges, I'm happy to report that we've got a lot of beneficial outcomes. We've achieved operational excellence for a certain number of our deployed AWS resources, at least the ones that our team maintains. In terms of mean time to respond, for the two case studies that I mentioned earlier, both for doing backups as well as Lambda functions, we were able, deployments, we were able to reduce the time that developers took to do that significantly, from some cases multiple days to a few hours and minutes. Once again, these use cases are very varied, so we don't have metrics on that. But over time, we'll gather more data and see how the transformation happens, and we'll get back to you with more information. In addition to that, now we can do deployments with greater confidence. We know that we have an automated test pipeline that does a lot of our work, so we don't have to spend time on that. In addition to that, as with our Lambda case, we've been able to achieve service recovery, once if a service runs into a failure, either in terms of a binary that's running in an EC2 instance, or which we re-executed through SSM documents, or a Lambda function that we redeployed, whose previous version we redeployed if it runs into any error state. With that, I'd like to conclude our presentation. I'll hand it back to Brian for closing remarks. Thank you so much. Okay.
Am I audible? Can you hear me? I'll project. How's that? We'll go with that. So a few common slides that you've probably seen before in the presentations. There's one about learning, training and certification. We have options that can also assist you. There's lots of mechanisms for that. I also recommend the Well-Architected Labs. They're open source. They're free to you. They're on GitHub, easily found at wellarchitectedlabs.com. And I'd like to say thank you for coming out this evening and staying through the whole session. If you'd like, we have time for questions. I see we have 5 minutes left on the clock. Please also complete your surveys. We can only benefit from feedback, good or bad. I would love to hear what you have to say. And with that, please come back up to the stage and we'll take any questions. There's a microphone back there, or if you just want to shout out, I will restate your question so everyone can hear what it is. Come on up, guys. Do we have any questions? Feel free to raise your hand, wave it about. There's one right here. Okay. Sir, what's your question?
I have two questions. First is, what is offsite item? Is it predefined, or you do like if there is some error, long level is error, then that is offsite?
So the question is, what is an ops item? Do you want to take that one?
Yeah, so basically we create ops items in response to errors. Like for example, like you mentioned errors, right? Like we'll see errors in our X-ray logs, and based on that, we'll have specific event rules to capture those, and then from that we'll invoke our Taskmaster Lambda function to look at that error log, and then inspect it and get more details about it, and create an ops item from that. We'll create ops item as an entity in OpsCenter, and then that'll be the source of all our information about a given event. And then we will tag it with appropriate information such that our downstream systems can respond to that.
So effectively, it's a container for your event.
Yeah.
The event that you're going to respond to. So realistically, you could compare it to an incident. So a container for the incident that is enriched with additional information to help in the response to that incident. Are there additional questions?
I think you had a second question, right? Yeah.
Oh, another second.
Yeah.
Yeah, you did a great job in automating all these things. So you are saying first time you detect, you run the script, second time it's automated. So there is some critical issue that is going on, but your automation is automatically fixing that.
So, as I mentioned,
Well, let's restate the question here, although I'm not sure what the question is. Your statement was the first time through, you treat it manually. Your second time through, you do it with automation. What's the question behind that?
It's like suppose there is some issue that really need to look into, but your automation script keep fixing it. Suppose there is a Java
I
Okay,
see.
so what is
or
the-
added details.
Let me
I
restate
guess,
the question.
Yeah.
The question was, what if your automated script keeps fixing your problems? What do? Because there's probably something underlying that you should address.
So as I mentioned earlier, we're trying to capture as much information as we can in our ops item, including the specific remediation task that we did. We associate that with the ops item, and then once the task is remediated, we'll close it, right? However, if you go to OpsCenter, you'll see a list of open and closed ops items. Over there, if you want to do post-remediation checkouts, the whole thing about after an event has happened, when do you do a whole lessons learned kind of thing, right? You can look at that, and then you can see, okay, I see that this specific error is happening way too often. We need to do something about it. So that, and you can create a new task and assign it to a developer to fix it. So that's where this comes into the picture.
So you're performing analysis after the fact and checking out your trend.
Yeah, if it's something that's repeatedly fixing, yeah.
Very good. There was another question.
Yes.
Sir.
I have a question.
Oh.
Yeah, sorry, maybe an interesting question, but how do you guys manage new events? Because one of the steps in your task where you get the event and you populate the event with some external context information from some stuff.
Yeah.
So I'm assuming that each new event that you have coming into the system, you have to have some additional context associated with it. So
Right.
how do you guys manage this whole,
Okay.
I don't know if the question makes any sense.
Right. So there are two things that are happening over here. Firstly, what we are doing is we're taking advantage of what is known as an organization cloud trail, in terms of in source of information, right? So what we do is given that we are a large organization, we have over 200 accounts in our production environment, right? So in there we'll capture events that are cloud trail events. If we take that as an example, we'll capture that from different sources and make it available on a single place. We don't even need EventBridge for this. We just using the organization cloud trail, which is enabled at the org level. Sorry for the pun, but yeah. Once it's there, we'll basically have EventBridge like look for specific events that we care about. One of those cases was like the Lambda update one that I mentioned, right? So once we have those, like we will get information about A, which account is it happening in from the ARN information, and then B, which region it's occurring in. And C, once we have details about the roles, we can actually like take action after that. One thing that I should mention as well is that for remediation actions, since our team is also responsible for vending these production accounts, we create like certain roles in the account in the beginning itself. So like our remediation functions at a later stage will assume into those roles and they then take those actions necessary to remediate that like specific event that we saw. Does that answer your question? Okay.
All right, there's another question over here somewhere. Sir.
I just wanted to get a sense of scale, like going through there and how many events are you getting, how many do you have automated responses for, and what's the feedback time?
Let me restate the question for you. What is the scale? How many Lambdas are there? What surface of workloads are you actually supporting with this?
So right now we are mostly looking at like Lambda functions that are operated and maintained by our team. And in those, like we have close to, I would say, 80 to 100 of them, like in terms of like some of them like take action against like badly misconfigured policies or resources. So while they have like a limited scope right now, we are still seeing like a very good performance in terms of like things getting detected and then that getting like picked up, and then like through our workflow process, we can do some testing and like do the automatic rollback if necessary. So we are able to do that with relative quickness. So if you look at our OpsCenter dashboard today for the account where we have all of this stuff, like whenever we upload a Lambda function, instantly it'll create like a bunch of different if you have multiple Lambda functions coming from say like the same Java file or like multiple classes, you'll see that they'll all be getting updated and all be running tests and stuff. So it's very, very instantaneous.
With that, I know that we only have a few seconds left, so I'd just like to say thank you for coming out again.
Yep.
And I hope you enjoy the rest of your night.
Yeah. Thank you.